Australia is a land of contrasts. From arid deserts to lush rainforests, its landscapes are as diverse as its wildlife. But how did this island continent come to be? To understand, we have to look back millions of years. Australia's journey started with a supercontinent known as Gondwana. Imagine a time when Earth's continents were not where they are today. Australia was once part of a massive landmass called Gondwana. Over millions of years, geological forces caused Gondwana to break apart. Australia began its slow, solitary drift, sculpting the unique environment we see today. The story of Australia's separation from Asia is a tale of colossal tectonic shifts. So let's embark on this fascinating journey through time and space, exploring how Australia drifted away from Asia and became the unique continent it is today. Long before the world had familiar continents, there was Gondwana. This supercontinent existed around 600 million years ago. It included land that would become South America, Africa, Antarctica, India, and Australia. Gondwana was immense, stretching from the South Pole to the equator. Australia's position within it was near the eastern edge, nestled against Antarctica and India. The climate of Gondwana varied greatly. In the southern regions, thick ice sheets covered the land. Closer to the equator, lush forests and vast deserts spread out. The diversity of environments provided a home for many ancient species. Dinosaurs roamed freely and primitive plants flourished. For millions of years, Gondwana remained stable, but deep beneath the surface, change was brewing. Movements in Earth's mantle generated immense heat and pressure. This caused the tectonic plates which make up the Earth's crust to shift. The tectonic forces began to tear Gondwana apart. Australia, once snugly fit within the supercontinent, began to move away. The breakup of Gondwana was driven by tectonic activity. This involves the movement of Earth's plates. These plates float on the semi-fluid layer of the mantle. Heat from the Earth's core creates convection currents in the mantle. These currents cause the plates to move. Over millions of years, these movements can cause continents to drift apart. In the case of Gondwana, the tectonic activity was particularly intense. Around 180 million years ago, the first signs of separation appeared. Rifts began to form between the African and South American plates. These rifts filled with magma, creating new oceanic crust. As the crust cooled, it formed the Atlantic Ocean, pushing the continents further apart. Australia's journey started around 130 million years ago. It began to separate from the eastern edge of Gondwana. This movement was gradual, taking millions of years to become noticeable. The forces driving this movement were immense. The formation of the Indian Ocean was a significant event in Earth's geological history. It began with the breakup of Gondwana. As the African and Indian plates moved apart, a new ocean basin started to form. It took millions of years for the Indian Ocean to reach its current size. The separation of the continents was driven by the spreading of the oceanic crust at the mid-ocean ridge. The collision between India and Asia would eventually create the Himalayas. As the ocean expanded, it influenced the climate and ecology of the region. Section 5. Australia's separation from Antarctica. Australia's separation from Antarctica was a pivotal moment in its geological journey. This event occurred around 85 million years ago. The separation was driven by the same tectonic forces that had broken up Gondwana. As the rift between the Australian and Antarctic plates widened, a new ocean began to form. This was the early stage of the Southern Ocean. The separation was not a sudden event, it was a gradual process that took millions of years. As Australia drifted away from Antarctica, the gap between the continents slowly filled with seawater. This process created new oceanic crust, which further pushed the continents apart. Volcanic activity was common during this time, contributing to the formation of the ocean floor. The climate of the separating continents also began to change. Meanwhile, Australia drifted northward, experiencing warmer and more diverse climates. Section 6. The birth of the Southern Ocean. The birth of the Southern Ocean was a significant event in Earth's geological history. It marked the final separation of Australia from Antarctica. This ocean now surrounds Antarctica and connects the Atlantic, Indian, and Pacific Oceans. Its formation was driven by tectonic forces shaping the Earth's surface. As the rift widened, seawater filled the gap, creating a new ocean basin. The Southern Ocean began to take shape around 30 million years ago. Over time, it grew to encompass the entire southernmost part of the Earth. The strong ocean currents around Antarctica play a crucial role in regulating Earth's temperature. Section 7. Isolation and the evolution of flora and fauna. Australia's isolation from the rest of the world had profound effects on its flora and fauna. Once separated from Antarctica and other landmasses, Australia became a unique evolutionary laboratory. The isolation allowed species to evolve independently, leading to the development of distinctive plants and animals found nowhere else on Earth. One of the most notable examples of this unique evolution is the marsupials. While placental mammals dominated other continents, marsupials thrived in Australia. Species like kangaroos, koalas, and wombats became iconic symbols of the continent. The flora of Australia also evolved in remarkable ways. The continent is home to some of the world's oldest and most unusual plant species. Eucalyptus trees, which dominate the landscape, evolved to withstand Australia's often harsh conditions. Australia's unique ecosystems are a direct result of its long isolation. Section 8. The Wallace Line, a biological divide. The Wallace Line is a fascinating concept in biogeography. It represents a boundary that separates the distinct species of Asia and Australia. The line runs through the Indonesian archipelago, dividing the islands into two distinct ecological zones. The islands to the west of the line have species similar to those found in Asia, while the islands to the east have species more akin to Australia. This division was first identified by the naturalist Alfred Russel Wallace in the 19th century. He noticed the stark differences in species on either side of the line. For example, tigers and elephants are found on the western side, while marsupials and monotremes are common on the eastern side. The presence of the Wallace Line highlights the impact of geological and climatic barriers on the distribution of species. The deep oceanic trenches and strong currents in the region have prevented the easy migration of species between the islands. Section 9. Unique Australian wildlife. Australia's wildlife is a testament to its unique evolutionary journey. The continent is home to a plethora of species found nowhere else on Earth. This biodiversity is a direct result of Australia's long isolation and distinct climatic conditions. From the iconic kangaroo to the elusive platypus, Australia's fauna is both fascinating and diverse. One of the most remarkable aspects of Australian wildlife is the prevalence of marsupials. These mammals, characterized by their pouches, are a defining feature of the continent's fauna. Kangaroos, koalas, and wombats are just a few examples. The evolution of marsupials in Australia is a result of the continent's isolation from placental mammals, which dominate other parts of the world. Australia is also home to unique bird species. The emu, a flightless bird, is one of the largest birds in the world. The kookaburra, known for its distinctive laugh-like call, is another iconic Australian bird. Section 10. The ongoing northward drift. Australia's geological journey is far from over. The continent continues to drift northward at a rate of about 2.7 inches per year. This movement is driven by the same tectonic forces that caused the breakup of Gondwana millions of years ago. The Australian plate is moving towards the Eurasian plate, bringing Australia closer to Asia. This ongoing drift has significant implications for the region's geology and climate. As Australia moves northward, it is slowly colliding with the Pacific plate. This collision is causing the formation of new mountain ranges and volcanic activity in the region. The movement also affects ocean currents and weather patterns, influencing the climate of both Australia and its neighbouring regions. The northward drift of Australia is a reminder of the dynamic nature of our planet. Section 11. Conclusion. Australia's separation from Asia is a story of immense geological change. It began with the breakup of the supercontinent Gondwana and continues with the continent's ongoing northward drift. This journey has been marked by volcanic activity, the formation of new oceans, and the rise of mountain ranges. Each of these events has played a crucial role in shaping the unique landscape and biodiversity of Australia. The isolation of Australia allowed for the evolution of distinctive flora and fauna. The continent is home to an array of species found nowhere else on Earth. From marsupials to unique bird species, Australia's wildlife is a testament to its long evolutionary history. As Australia continues its northward journey, it remains a fascinating subject of study for geologists and biologists alike. The continent's dynamic geological history provides valuable insights into the processes that shape our planet.